Hello everyone, in this video we will go over section 3.2. So section 3.2. So we are going to do essentially only one thing new, and is that we're going to use radians to measure the angles instead of degrees. But everything else is the exact same thing. So the only difference is going to be we're going to use radians instead of degrees. So what is a radian? So remember that from what we know so far, if you go around the whole 4 quadrants, you have 360 degrees. So therefore 360 degrees is going to be equivalent to 2 pi radians, which means that pi is going to be 180 degrees. So therefore the conversion factor, which we're going to see right here, so it's no accident that this is equals to pi over 180, is that if pi is equals to 180 degrees, that means the 1 is equals to pi over 180, or 180 degrees over pi is equals to 1. So this is going to be the conversion factor. And in reality, every time you want to convert from one thing to another, technically you only multiply by 1. So in this case, the one we're going to use is either this one or this one. So therefore, you want to change from radians to degrees, you're going to multiply times pi over 180. So for example, let's say you want to change 45 degrees to radians. So you're going to multiply this by pi over 180. And then notice that 180 is the same thing as 45 times 4. So therefore the 45 will cancel, and that means that you will get pi over 4. So essentially 45 degrees is the same thing as pi over 4 radians. All right, let's try a couple more. Let's say you want to change 30 degrees, so you multiply it by pi over 180. And again, 180 is now 30 times 6. The 30s will cancel, so this will give you pi over 6. So this means, therefore, that 30 degrees is the exact same thing as pi over 6. All right, let's do one more. Let's say you have 60 degrees. You multiply by pi over 180. Same trick. This will be 60 times 3. This one cancels now, and this will give you pi over 3. So that means that 60 degrees is the exact same thing as just pi over 3 in radians. All right, so the main thing that we care is to be able to change from degrees to radians, because from now on, most of the time, things will be done in radians. And if you take calculus, everything is done in radians. In calculus, they don't use degrees. It's very rarely they will use degrees. So you should also be able to go backwards by using the other conversion factor. So instead of multiplying by pi over 180, you multiply by 180 over pi. So let's try that next. So to convert from radians to degrees, now you want to multiply by 180 over pi. So for example, let's say you have 3 pi over 4, and you want to know what that is in degrees. So we're going to multiply this by 180 over pi. Notice that the pi's will cancel right away. And then 180, we already say it was 4 times 45. So the 4's cancel, and now this will be 45 times 3, which is 135. So therefore, 3 pi over 4 is the same thing as 135 degrees. All right, let's try one more. Let's say you want to change now, let's say 3 or 4 pi over 3. So 4 pi over 3, you multiply by 180 over pi again, and the pi's will cancel right away. Remember that 180 was the same thing as 60 times 3. So the 3's cancel, and you'll end up with 240 degrees. So therefore, 4 pi over 3 is the exact same thing as 240 degrees. Now the next problem, we have done multiple times problems like this in the past. The main difference now is that we're going to use radians instead of degrees, but it is technically the same problem, so therefore the answer should be the same. The advantage also of radians is the following. Look, 3 pi over 2, we already say from here, from the previous problem, from here, it was 135 degrees. So therefore from here to here is 135 degrees, which is 3 pi over 4. Okay? And remember that in order to find these values, you don't use 135. You actually use the reference angle. Here is the good advantage, or an advantage of using radians. This is usually going to be the reference angle. So in this case, the reference angle is actually pi over 4. But remember, pi over 4 is the same thing as 45 degrees. And therefore, if we use the special triangle, which I told you a few times now that you should memorize, this will be 1, 1, and radical 2. This is if it is 45, 45, 45, which now you could say pi over 4, pi over 4. Also notice that you are in the second quadrant. But first, so sine of 3 pi over 4 will be sine of this, which is 1 over radical 2 or radical 2 over 2, whatever you want to simplify to. And therefore cosine of 3 pi over 4 is the same, radical 2 over 2. And tangent of 3 pi over 4 is equals to 1. Now from here, remember that if this is the case, well then cosecant of 3 pi over 4 was radical 2 over 1. The same thing for secant. So we have done this a few times by now, and therefore cotangent of 3 pi over 4 will also be 1. Now the last thing you have to check is what we have done a few times too. Remember here all of them are positive, here only sine, here is tangent, and here is cotangent. Since you are in the second quadrant, only these two are positive, which means this is negative, this is negative, it's negative, and this is negative. So this is identical to what we did before. Again, the only difference is that we're using our radians instead of degrees. Okay, so let's do one more example. All right, so here the angle actually should have been 7 pi over 6. Okay, so 7 pi over 6, you can change first to degrees, which usually that's what you have to do first if you are not sure where you at, because remember you need to know which quadrant you are in. All right, so if you want to change 7 pi over 6 to degrees, remember you're going to multiply by 180 over pi. The pi's cancel. This is equals to 6 times 30. So the 6 cancels, so you end there with 210 degrees. And remember 210 degrees, this is on the third quadrant. So you need a reference angle, and the reference angle is actually 30 degrees. And as you can see from here, you have pi over 6. Remember that we already converted pi over 6, and pi over 6 was equals to 30 degrees. I highly recommend you also to memorize this conversion so you don't have to do it every time. So therefore the reference angle is 30 degrees. So remember from here to here, this is 7 pi over 6. This one is pi over 6. By the way, a fast way to also convert something like this to degrees If this is 30 degrees, how much is 30 times 7? Well, it's 210. So then this gives us again the special triangle where this is 30 degrees, 60, and obviously this is 90, so this is 1, 2, and this is radical 3. So therefore finding sine of 7 pi over 6 is the exact same thing as finding sine of 30. But sine of 30 we already know is 1/2. This means cosecant of 7 pi over 6 is now going to be 2 over 1. And then cosine of 7 pi over 6 is going to be radical 3 over 2, which means secant of 7 pi over 6 is going to be 2 over radical 3. And then finally tangent of 7 pi over 6, this is going to be 1 over radical 3, which means cotangent of 7 pi over 6 is equals to radical 3 over 1. Now the last thing to check is which quadrant you're in. Here all of them are positive, here only sine and cosecant, and here tangent and cotangent, and here cosine. Since you are on the third quadrant, that means this one is negative, this is negative, this is negative, and this is negative. And that's it.